Welcome to the SPSS tutorial video on correlations and partial correlations. Today we'll be covering Pearson correlations. These are sometimes called zero-order or bivariate correlations, as well as how to calculate partial correlations in SPSS. The data we're using today is a therapy data file. Because we'll be looking at correlations, we will only be examining continuous variables. Correlation should only be calculated for continuous variables. So variables that we've used in previous videos, such as therapy type or participant sex, which is listed as female, these are categorical variables and inappropriate for use in correlations. Today we'll be looking at the correlation between depression at time 1 and between depression at time 2. We'll also be looking at the correlation between depression at time 1 and depression at time 2, controlling for optimism. This is the purpose of the partial correlation. We'll get the partial correlation between depression at time 1 and time 2 while controlling for optimism. To calculate a correlation in SPSS, we'll go to Analyze, then Correlate. The first analysis we'll do is a bivariate correlation. Again, I said that Pearson correlations are often called zero-order or bivariate. You'll notice that in these small checkboxes below, there are actually different types of correlations we can calculate. For most statistics used in psychology, we're talking about the Pearson correlation coefficient. To calculate a correlation, we'll move over depression at time 1 as well as depression at time 2. Now notice that we can move several other variables over, including optimism, for example, socioeconomic status, for example. And when we do this, it'll create a correlation table that includes all of these. For now, we're only going to look at the depression scores, so I'll move these two variables back. Once we click OK, in our output, we see that we get a table that has 4 cells. You'll notice that the diagonal, which includes correlations with depression at time 1 with itself, depression at time 1, is always going to equal a 1. The second, depression at time 2, correlated with itself, depression at time 2, is also a 1. What we're more curious about is the correlation between depression at time 1 and time 2. This indicates whether depression is stable across time or whether it changes, whether these two things are highly unrelated. In this case, we get a correlation of 0.895, which is incredibly high. It is statistically significant at less than 0.001 for our sample of 150 people. You'll notice that in the off diagonal, or these two cells here, we get the same number reflected. This is because it shows us the same correlation twice within a cell. Whenever you're looking at a correlation table in general, when you have more than 2 variables, you may have 3, 4, or even 10 variables at a time. It's often helpful to either look at the upper diagonal, which is the numbers above this row of 1s, or the lower diagonal, which is the numbers below the 1s, because it's simply reflected and shows the identical thing. Now let's examine a partial correlation coefficient. To examine a partial correlation, we'll go to Analyze, again to Correlate, but this time instead of choosing bivariate, we'll choose partial. The two variables that we want in our analysis are depression at time 1 and depression at time 2, and the variable we want to control for is optimism. This analysis will give us the correlation, or more specifically the partial correlation between depression at time 1 and depression at time 2 after controlling for or covarying optimism. Click OK. Scroll down. Here we see that the correlation between depression at time 1 and time 2 controlling for optimism is just slightly lower than it was in the zero-order or the Pearson correlation. It reduced from 0.895 to 0.890. This is not a big difference. In some cases, when you control for variables, you'll see a very dramatic change. In this case, the change was subtle, and the correlation between depression at time 1 and depression at time 2 while controlling for optimism remains statistically significant.